In the previous video, we've talked about making a scatter plot, wherein in our x-axis is our independent variable, which was in our example dexterity test scores, while in our y-axis, our dependent variable would be the units produced in 1R. So now that we have a scatter plot, this is just a visual description of a possible relationship, but we want to know the exact nature of that relationship. In regression, we aim to build a model for y given some x or x's. The process is called model building or modeling. This model is represented by a y as a function of the x or the x's. For basic statistics, the function is linear. But do take note that there exists non-linear regression. So what we would have, that's why our topic is called simple linear regression. It is because we are only on the basics of our statistics, but do take note that there exists a non-linear regression. In linear regression analysis, we aim to find a line that best fits the data. This is what we call the least squares regression line. Now, we will go to Excel to find how do we find that line that best fits the data or the least squares regression line. So here we are in our Excel, and this is our graph a while ago. So if we select, we can actually look for the line that best fits the data. So we would select this here, the chart elements. We would go down and select the trend line. By default, what Excel will give us is a line. But actually, when you select trend line, there are other, and like what we said, there are more than one type of regression, and not everything is linear, but we will select linear. And let's just have that. Let me just, here are the other options, and let me just adjust the way it looks for a while. So there we go. I adjusted it so it will have a different color. Let's take a closer look. So here. Now, as you can see, this line, this trend line here actually will somehow fit some of the points, or it will have a very small distance away from the points. Further, if we will try to continue this line, we can actually try to predict what would be the other points here. Or, if we will try to continue this, we can see how many units produced per hour we will have if their dexterity score is, say, 18. What would be the data point here? What we can do, we can simply continue that line until this one. So this would be this point here. If we're going to continue this line, that would be the point wherein that would be the number of units produced given that the dexterity score would be 18. And that is how we make what we call the trend line, or the line of best fit, or the least squares regression line in Excel. This line here actually will actually help us know what is the type of relationship that this one has. It might not be exact, but since, as you can see, if we take a look at the closer again, the differences from the actual point to the line might be not significant statistically. So we can still say that this line fits these points the best with their respective distances away from the line, or the respective differences from the line, to if it is insignificant. So in algebra, such a line may be represented by y equals mx plus b. In statistics, this is usually denoted by y equals beta sub 0 plus beta sub 1 x. Now, we call our linear regression analysis simple because there's only one independent variable. And we call it linear because we already said that the y and x are assumed to be linearly related. So, our relationship, its nature, can be actually described as an equation of a line, which is actually y hat equals beta sub 0 hat plus beta sub 1 hat x. Now, the first thing that you would notice a while ago, this was just y equals beta sub 0 plus beta sub 1 x. How come here we have now these hats? This 3 is because we are dealing with sample data. Because we don't have the population data, we will have the sample data rather. And also because these are just estimated values. Because they are from the sample data. Now, formula-wise, this is how we will compute for beta sub 1 and beta sub 0. Thankfully, we will compute them using Excel. It will be the one to compute for us. Instead, we are concerned of their meanings. Beta sub 1, this is the estimated increase in y for every unit increase or decrease depending on the sign in x. For example, we have this equation y hat is equal to, let's say, 4 plus 5x. Now, our beta sub 1 is the one beside x. Always remember that, so it's this one. So what does this mean? This means for every increase, for every unit, 1 unit, for every 1 unit increase in x, y hat increases by 5. So that means if, for example, my x is 1, my y hat should be increased by 5 because my x increased by 1. So that's what beta sub 1 means. Beta sub 0 is the estimated value of y when x is 0, although not always interpretable. Say for example again, we have y hat equals 4 plus 5x. This is actually the value of y hat if x is equal to 0 or the independent variable may not exist. So this is the default value, as we can say, of our y hat if we don't have our independent variable x. So we will use y hat equals beta sub 0 plus beta sub 1 x hat as our linear regression equation. Linear regression equation.